Sida, are you with us?
Yeah, here I am. Hey, how are you doing?
Sida, I'm doing very well. Remind me, where are you located?
Menlo Park, in the Bay Area.
Menlo Park in the Bay Area.
Yep.
Join us. We're gonna have a nice conference, a mini conference, unconference, whatever. It'd be nice to see you there. We have about
Absolutely.
we have about 10 minutes. I want to make sure that you have all the time that you need. So take it away, man.
Thank you. Appreciate that. Appreciate that. So today we're gonna talk about customer-facing analytics. Right now, we're not gonna only talk about how to make it fast, but we also want to talk about how to make it not break your data governance, not break your whole data pipeline. Right. So first, get started. So first, what is customer-facing analytics? Customer-facing analytics basically directly serving your analytics to your end user. Right. So on the right is a screenshot of our YouTube studio page. You can see the real time number of views, watch time, and subscribers. For that particular video, right? This is customer facing analytics right there, right? One characteristic is that it's extremely high stake. It's typically your revenue driver, so your competitive advantages against your competitors, right? Some example industry can be martech, fraud detection, and or just in general, external facing dashboards that are powered by OLAP style queries, right? So one characteristic of customer facing analytics that's different than those like internal facing analytics is the impossible SLAs, right? So the SLA requirements are really, really high. So you have to get very low latency, even under crazy amount of loads, right? Thousands or sometimes even hundreds of thousands of concurrent users, right? So for some of our users, their QPS number can be somewhere in the thousands, or even to the tens of thousands of QPS, right, for OLAP queries. And there's absolutely no room for error, right? And there are also it's very also very difficult to do technically, right? So first, your workload changes, right? You don't know when your customer is going to issue a whole bunch of queries, it's going to overwhelm your whole cluster, right? And also you have infrastructure failures because the SLAs for a lot of the customer facing like workloads are so strict that they're even more strict than some of the cloud infrastructure that's running on, right? So if your cloud infrastructure fails, you need to have something that to fall back to, right? Also, you're not only serving one customer, you're serving many of them, right? So you run into resource contention issues, right? So how do you make sure that all of your customers have the right amount, the appropriate amount of resources, to correctly run their business, right? And also, when data gets updated, new data being added, right? You have cache misses, you have index that gets outdated, your statistic gets outdated, so your query planner takes a hit, right? And those are the main generators, for those slow queries that is just not acceptable for customer facing like workloads, right? And also when it fails, you run into slow dashboards, timeouts, right? Breach SLAs, right? And also if your system doesn't scale that well, you have to over provision, for those rare peaks, right? And end up your team, you're stuck firefighting instead of actually building, and to serve your customer, right? So, yeah, so this is customer facing is very, very difficult to do, right? And people's been doing customer facing analytics on proprietary system all the time, and they thought proprietary system was the only way, right? And yeah, it does solve, a lot of the performance challenges, using something like a proprietary data warehouse to directly serve, those customer facing like dashboards. Yeah, but it comes with a whole new set of challenges and costs, right? So on the right, we have an oversimplified architecture of what your architecture might look like. You have a source of truth as your data lake, and then you have data warehouse on top, just for query acceleration, right? But first, you have to consider the cost of actually maintaining that proprietary data warehouse. It stores a lot of data, right? It uses a lot of compute, right? It's very error prone and expensive. And also, you have to consider the cost of the data ingestion pipelines, not only to your data lake systems, but also to your data warehouse. Not one table, but most often thousands of tables that running ingestion pipelines really expensive to maintain for petabytes of data, right? And also you have the challenges from matching the schema data type SQL from your source of truth to your data warehouse, right? And that's very, very difficult to do, right? Schema design and new index designs, right? Those are really challenging to do. And also, most importantly, you're going to run into data governance challenges, right? You don't really have your single source of truth anywhere anymore, right? You're basically copying your data the same data to 15 different places, just for query acceleration purposes, right? And this is going to run you into a data governance nightmare, right? So why is running high performance query on the lakehouse today seem that challenging, right? Because a lot of the query engines that are used for data lake or data lake houses today are not really built for consistently fast query performance, right? A lot of them are still optimized for those classic data lake kind of workloads, long running batch like ETL workloads, not really low latency, high concurrency like queries, right? So what are some of the essentials, to have low latency, high concurrency like query performance to power your customer facing analytics workloads on open data, right? So first is a hierarchical caching framework is absolutely necessary, right? Data lake houses such as Apache Iceberg, they do really well with object storage, with cloud object storage, right? But the response time of a cloud object storage, such as AWS S3, can be upward to 100 milliseconds, right? And when we issue a query from the query engine side, that's just not one query scan. That's many query scans, and each one of them takes 100 milliseconds to respond. And it's just not fast enough for customer-facing workloads, right? And also, you want to find something that's built for low latency, joins a high cardinality aggregation queries, right? So first is cost-based optimization, right? Optimizer or query planner is probably one of the most important part of the query engine, right? So it dictates, what query path we take, right? A optimized query plan and inoptimized query plan can be a difference of hundreds of times difference, right? And also you want to find something that's MPP, right? Massively parallel processing, right? So do data shuffling. Not only it does data shuffling, but also do data shuffling between the memory of your nodes, right? To be optimized for low latency joins instead of batch kind of workloads, right? And also you want to find something that's optimized for performance, something that's written in a lower level language such as C++, to fully utilize SIMD instruction sets, so we can parallel process, and we can process data in batches instead of row by row, right? The more batch you run, the faster your OLAP query is gonna go, right? So actually, with all of those, getting data warehouse like performance on Lakehouse is not only possible, it's actually quite easy to do, right? So here is Starrocks. Starrocks is a Linux Foundation open source Lakehouse query engine. It's a query engine built for low latency, high concurrency like workloads. Has an MPP architecture that does data shuffling in memory between nodes memory, right? It also has a C++ SIMD optimized execution engine, right? That's fully vectorized as well. And also has a cost-based optimizer, to ensure that all of your joins and aggregations are optimal, right? So to run your sub-second query latency, with very high concurrency, to run those data warehouse-like workloads directly on open table formats, such as Apache Iceberg, Delta Lake, Apache Hudi, Govern, Parquet files, right? So Starrock's base performance is very good. So versus Trino is around 4.6 times faster than Trino on TBCDS 1 terabyte, right? So the base performance is really good. Actually, one thing I don't really like about performance benchmark is it just doesn't tell the full story, right? It tells a good story about the base performance of your system, but the most important thing for customer facing analytics is actually how to solve those slow queries, right? We talk a lot about slow query and caching, right? Why caching is important, and a cache miss can produce, slow queries, right? So we absolutely want all of your data that's going to be scanned to be scanned from a cache, right? So we build a proactive cache warm-up, to make sure that even your first query is fast, right? And we also have compute replicas for cache to make sure that even your instances fail, one of your compute nodes fail, right? You have another copy of the cache to fall back to, right? To ensure the best possible performance. And also segmented RRU to make sure that a single big query scan is not going to invalidate all of your data, hot data in your cache, right? And also low latency on the lakehouse. Statistic collection, low cardinality dictionary, right? Those are data warehouse like features we're porting to open data, to open storage, right? And also start smart metadata handling, right? Specifically tailored for each one of the open table formats. For example, your Apache Iceberg metadata, right? When it grows to terabytes, how do you parallel read that metadata? And how do you handle equality deletes? How do you accelerate the merge of the equality delete files and your data files, right? And that's something that actually your query engine can help with. a lot, right? And also to ensure query plan stability, to eliminate all of the slow queries. Adaptive parallelism to automatically allocate the right amount of resources, for your kind of workload, right? And query cost prediction to identify and isolate those big queries so they don't affect other kind of queries in your cluster, right? So task retry and phase scheduling, for better false tolerance as well, right? So here are some examples of customer facing analytics that's running on open data, on open lakehouses. So first, TRM Labs. TRM Labs is a financial platform, that secures your cryptocurrencies. And this is the Iceberg Summit 2025 talk, right? And they run their customer facing analytics on 100 terabytes of data that's growing 25 to 45% annually, right? With complex joins and high cardinality aggregations with a 3-second P95 SLA requirement, right? And they were on BigQuery and they were running into performance bottlenecks. And then they moved to Apache Iceberg and they were picking a query engine on top of their Apache Iceberg Lakehouse. They considered Trino, Starox, and DuckDB, right? And they finally picked Starox and saw 50% performance improvements in their P95 and 54% reduction in query timeout errors. And the next one is HerdWatch. It's external facing dashboards for livestock, for cows and goats, right? And before they were running on Athena on top of Apache Iceberg, and they just grew out of Athena, right? As their business grew and their latency was just too high, bottlenecks, right? And they moved to Starox and dropped the latency from minutes to around 1 second, right? So they kept their single source of truth on the Apache Iceberg with even simplified governance because no more need to ingest into another data warehouse for performance acceleration and end up getting better performance after all, right? This is all I have. If any of that sounds interesting, be sure to join the Stardock Slack channel using that link or the QR code right there.